Hi there. Hope you have a fantastic day. This lesson I will teach you probability involving Venn diagrams. Of course, there's the PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one. John has a jar containing 5 red, 3 blue marbles. He draws 2 marbles without replacement. So we need to complete the tree diagram. So without replacement means he draw 1 marble out and then draw the second one. Okay, I'll put the first one back to the draw. So let me just analyze this for you. So John has 3 red marble and 3 blue marbles. So let me just write this down. So red is 5, blue is equal to 3. So the probability getting a red for the first draw will be 5 out of 8. The total number of marbles are 8. So that means the probability getting a red is 5 over 8. So which is done for us. And to get a blue, we have blue marbles here. That is 3. So 3 out of 8. So 3 out of 8. There you go. So let's say the first drawn, that is red. So this means that red 5. Now the second drawn will be 4 left. Because John already picked a red marble. So only 4 left. Okay. So the total number of marbles now is 7 instead of 8. Keep that in mind. So therefore, the probability getting a red will be 4 out of 7. So which is done for us. Now the probability getting a blue for second drawn will be, blue will be 3 out of 7. So that is 3 out of 7. So there you go. Don't forget, okay, these 2 branches add up must give me 1 whole. And same as this branch here, add up must give me 1 whole. Because the total probability is equal to 1. Now, if the first drawn is blue, so this means that the blue now, 3 becomes 2. So the blue now is 2. And the red one still 5. Because the first drawn is blue. So 1 blue taking out. So should be a blue will be 1 less. And the red marble still 5. Now the probability getting a red for second draw will be 5 out of 7. Okay, keep that in mind. And it's done for us. Now the probability getting a blue will be 2 out of 7. Because there are 2 blue marbles left. So 2 out of 7. So there you go. Now part B. Find the probability that both marbles are red. So both marbles are red. That means red, red. So there you go. 5, 8 times 4, 7. Let me just write this down. So the probability getting a red and a red will give me 5, 8 times 4, 7. 5, 8 times 4, 7. So that is, I just go 5 over 8 with times 4 over 7. So there you go, 5 over 14. Part C. Find the probability that the second marble is blue. So second marble is blue. So that is, this is second drawn. Is blue. So therefore, we need this branch. It doesn't matter what color is the first one. We only focus on the second. Okay, the second marble is blue. So second one is blue here. So that's the one. There you go. So this branch here, the probability red, blue is 5, 8 times 3, 7. And blue, blue is 3, 8 times 2, 7. So we just add these 2 probabilities together. So that means the second marble is blue is same as probability blue blue or red, blue. Okay, keep that in mind. So that means 5, 8 times 3, 7. 5, 8. We times 3, 7. We add 3, 8 times 2 over 7. That is, so I just go 5 over 8 times 3 over 7. And we add 3 over 8. And we times 2 over 7. So there you go. The answer is 3, 8. There you go. Please stop the video and try this one yourself. Hi there, I'm back. How do you go? Let me go through it with you. Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So we know that there are 3 black pens and blue is 2. So this means that there are 5 pens in a pencil case. So this means that the probability getting a black will be 3 out of 5. So the total is 5. For the first draw will be 3 out of 5. And to get a blue pen, so there are 2 together, so 2 out of 5. There you go. Let's say the first drawn is black pen. So that means the black pen for the second drawn will be 2 left. The total is 4. All together if you add them up. So therefore, the probability getting a black pen for the second draw is 2 out of 4. Okay, because only 2 black pens left. And then the total is 4. Because 5 of them, 1 already been drawn out. So now, the probability getting a blue pen, blue is 2. So that means 2 out of 4. So there you go. Let's say the first drawn is blue. Okay, so the first drawn in blue. So this means that the blue will have 2 of them now become 1. And the black pen, we still have 3. Okay, the first drawn is blue. So therefore 2 of them, so 1 left. So now the probability getting a black pen is 3 out of 4. So which is done for us. And then the probability getting a blue will be 1 out of 4. Because only 1 blue pen left. So that means 1 out of 4. So there you go. Now part B. We need to find the probability that is 2 pens are black. Both of them are black. So that means black here, another black. So now we just time them together. So the probability I can write like this. Okay, black and black. That is 3/5. We times a half. Or 2/4. Yep. So that is equal to, so we just go 3/5 times a half, give me 3/10. Otherwise, just put on a calculator. Now, part C. What is the probability that the second pen is blue? So second one is blue. So we just focus on the second one. Let me clear this. So the second one is blue. So this one here. So we need this branch. And the second one is blue. So we need this branch. So this branch here is 3/5 times or 2/4. So this probability here, 2/5 times a quarter. So we just add them up. Okay, the second drawn must be blue. So that it can be black blue or blue blue. So that both of them. So now we just write it down. So the probability blue or that will do. So that is, we have blue is this one here, which is 2/5 times a quarter, we add 3/5 times 2 4. So that is equal to, so just go 2/5. We times 1/4 and we add 3/5. We times 2/4. So there you go, 2/5. There you go. Please stop the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through them with you. First of all, we know that apple is 4 of them. And Sophia has 3 orange sweets. The total number of sweets are 7. So therefore, for the first draw, so the probability get an apple sweet is 4/7, correct? So it done for us. So now the probability getting an orange sweet is 3 out of 7 because there's 3 of them. So there you go. So if Sophia first drawn is an apple, so this means that the apple 4 now becomes 3. And orange still the same because it's just 1 apple sweets been taken out. So that means 4 apple sweets become 3. So now it's 6 altogether. So the probability getting an apple sweet will give me 3 out of 6. Because 3 apple sweets left. And the probability getting an orange sweet is 3 out of 6 as well. So 3 out of 6. So there you go. Now, if Sophia first drawn is orange, so that means orange 3 becomes 2. Keep that in mind because 3 and 1 being drawn out, that becomes 2 left. So now the apple 4 stay the same. Keep that in mind because 1 orange sweet been taken out. So therefore 3 orange sweet become 2 left. And then the apple stay the same. So that becomes 6. So to get a probability of an apple is 4 out of 6. And for an orange become 2 out of 6. So there you go. This is 3 diagrams. So now part B. Find the probability that both sweets are the same flavor. Same flavor means like this. Apple, apple. Orange, orange. So this, the 2 probabilities, that's what we need. So that means probability apple, apple, or orange, orange. That would do. That is 4/7 times 3, 6. Then we add 3/7. We times 2, 6. That is equal to, I just go 4/7. We times 3/6. Then we add 3/7. We times 2/6. 3/7. There you go. Part C. Find the probability that the sweets are different flavors. So that means we have this one here. Apple, orange. Or orange, apple. Okay, we need these 2. So that is 4/7 times 3/6. And then we add 3/7 times 4/6. So let me just write this down here. So probability equal. That will do because I run out of space here. So now we just go 4/7 times 3/6. We add 3/7 times 4/6. So that is equal to, so that will give me 4 over 7. We times 3 over 6. Then we add 3 over 7. We times 4 over 6. 4 over 7. There you go. Part D. Find the probability that is at least one sweet is apple. So at least one apple means this one here. At least one apple. So apple, apple. Apple, orange. Orange, apple. So at least one apple. So this means that we do not want 2 orange. Okay, we do not want this one here. So that means 1 minus 3 over 7 times 2 over 6. So let me write this down. So 1 minus 3 over 7 times 2 over 6. That is, I just go 1 minus 3 over 7. We times 2 over 6. So there you go, 6 over 7. There you go. Please stop the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through it with you. So let me complete the tree diagram first. So first of all, we know that dark chocolate, so that means D, dark chocolate is 6. And milk chocolate is 3. So the number of chocolates will be 9. So the probability for the first drawn will be, for dark chocolate will be 6 out of 9. And for milk chocolate will be 3 out of 9. So it done for us. So now if a dark chocolate been drawn, so this means that dark chocolate now 6 become 5 because one of them is being drawn. So that become 5. So the total number of chocolates for the second drawn will be 8. So that means the probability getting a dark chocolate, so that will be 5 out of 8. And for milk chocolate will be 3 out of 8. So there you go. So this is 5, 8, 3, 8. Add together, give me 1 whole. So keep that in mind. Now imagine the first drawn is milk chocolate. So this means that the dark chocolate for the second drawn still the same. And the milk chocolate 3 becomes 2 because the first drawn is milk chocolate. So that one of them been taken out. So 2 left. So the total number of chocolate is 8. So now the probability getting a dark chocolate for second drawn will be 6 out of 8. And to get a milk chocolate will be 2 out of 8. So there you go. Part A is done. Now part B, find the probability that both chocolates are dark. So that means this branch here. Dark, dark. So let me just write this down. Probability DD will do. Dark, dark chocolate. 6, 9 times 5, 8. That is, so we just go 6 over 9. We times 5 over 8. So 5 over 12. So there you go. Part C. So we need to find the probability that chocolates are different type. So different types means dark, milk, milk, dark. And we just add them up. So that means probability of different. That would do. So that means 6, 9 times 3, 8. And we add 3, 9 times 6, 8. That is we just go 6 over 9. We times 3 8. And we add 3 over 9. We times 6 8. A half. So 1 over 2. So there you go. Part D. Find the probability that at least one milk chocolate is selected. At least one milk chocolate. That means at least one milk chocolate means this or this or this. Okay, so that means we do not want this one. So easier, we just go 1 minus this branch out. Okay, so let me just write this down. That is, probability is equal to 1 minus 6 9 times 5 8. So that is equal to, so we just go 1 minus 6 over 9. We times 5 over 8. 7 over 12. So there you go. Please stop the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through them with you. So first of all, let me just complete the tree diagram first. So first of all, we know that there are 4 bananas. So B is 4. Apples is 6. So the probability getting a banana would be 4 out of 10. Okay. So first of all, 4 out of 10. And the probability getting an apple is 6 out of 10. If the first fruit is banana, so therefore the probability getting the banana on the second one, so that should be 3 here. Now the probability of getting a banana will be 3 out of 9. And the probability getting an apple will be 6 out of 9. There you go. Now, if the first fruit is apple, so that means apple 6 now becomes 5. 5. And bananas still 4 left. So altogether is 9 instead of 10. So now the probability getting a banana is 4 out of 9. And the probability getting an apple is 5 out of 9. So there you go. Now, part B. Find the probability that both fruits are apples. So that means apples, apples. This one here. So that is probability of AA. Apples, apple, apple. 610, we times 5 9. So that is, I just go 610, we times 5 9. 1/3. Part C. Find the probability that exactly one banana is taken out. So taken out exactly one banana. So that would be this one here. Or this one. Okay, exactly one banana. So that is 410 times 6 9. Let me just write this down. Probability. For 10 times 6 9, we add 610 times 4 9. That is, I just go 4 over 10. we times 6 9. Then we add 6 10. We times 4 9. 8 over 15. So there you go. Patty, find the probability that at least one fruit is banana. At least one fruit is banana. So that means we do not want apple. We don't want this, okay? We want everything else, see? 2 bananas, 1 banana, 1 apple, and 1 apple, 1 banana. We need this. So we just need to have 1 minus this one out. 6 10 times 5 9. So we just go 1 minus 6 10 times 5 9. Yep. I just go 1 minus 6 10 times 5 9. So there you go, 2/3. There you go. Please stop the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through it with you. So let me just complete the diagram first. So first of all, we know that Jack has this number here, 2, 3, 3, 4. So therefore, the probability that he get a 2 for the first draw will be a 2, a 3, or a 4. So therefore, the probability getting a 2 is 1 out of 4 because 4 cards, only 1 2 there. So the probability getting a 2 is a quarter, 1 over 4. Then the probability getting a 3 will be 2 out of 4 because 2 3s all together. So 2 out of 4. And the probability getting a 4 is 1 over 4. So there you go. And these fractions add together give me 1 whole. So that means I'm correct. Now imagine if Jack pick a 2. So that means we only have 3, 3, 4. Okay, so that means we either have a 3 or a 4 for the second draw. So that means to get a 3, the probability will be 2 out of 3. Because 2 numbers and all together 3 cards. So that means 2 out of 3. And the probability getting a 4, which is 1 out of 3. Because 3 cards left. 1 out of 3. So let's say the first card he picked is a 3. So 1 of the 3 gone. So we have 3 cards left. Okay, keep that in mind. So the probability getting a 2 is 1 out of 3. And the probability getting a 3 is 1 out of 3. And the probability getting a 4 is 1/3 as well. So let's say the first card he picked is a 4. So let me just clear this first. So a 4. First card is picked is a 4. So the 4 gone. So the second card he draw will be either a 2 or a 3. But then the probability getting a 2 will be 1 out of 3. Because only one number 2 and 2 cards are 3. So the probability getting a 2 is 1 out of 3. And the probability getting a 3 will be 2 out of 3. So there you go. This is probability tree. Part B. What is the probability that both cards are even numbers? So both are even. So this means 2, 4. And we have 4, 2. And that's it. So that means we have these 2 branches there. So that means 1/4 we times 1/3. And then this one here, 1/4 we times 1/3. And we just add them together. So that means 1/4 times 1/3. And we add 1/4 we times 1/3. That is, we just go 112 times 2, or we just add 112. Because a quarter times a third is 112. Otherwise, just put exactly how it is on your calculator. So the answer is 1/6. Part C. What is the probability that the first card is odd and the second card is even? So first card is odd and second card is even. So that means only this one here. And the even will be this and this. So keep that in mind. So now let me just write this probability down. So that means this one here is 2/4 and times a third. And this one here is 2/4 times a third as well. That's it. First odd, second is even number. So that means 2/4 times a third. That's right. And then the same thing. We can just add it again, or we just times 2. That will do. That is equal to 1/3. So there you go. Part D. What is the probability that at least one card is odd? At least one card is odd. So we don't want two even numbers. So let me just cross out the two even number, because at least one of them is odd. So we don't want two even. So we don't want this one, and we do not want this one. That's it. So we just go 1 minus these two probability out. So let me just clear this. So this one here is a quarter times a third. And this one here, a quarter we times a third. So that means 1/4 times 1/3. 1 minus 1/4 times 1/3. We minus 1/4 times 1/3 as well. Remember, we want at least one card is odd. So that means we do not want two even numbers. Okay, so that's why we go 1 minus this out. So just go 1 minus 1/4 times 1/3, and we minus 1/4, and we times 1/3. 5/6. So there you go. Thank you so much for watching. Bye.